This is the first section of reading for chapter 17 about probability models. And in this section, we're looking at the geometric model and the binomial model. But before we talk about those, we have to talk about Bernoulli trials, because for both of those models, the trials must be Bernoulli trials. Now, Bernoulli trials require three things. One is that there are only two possible outcomes, success or failure. Okay, now with that said, you can kind of group events together to be successes and failures. For example, I can roll a dice, and in my mind, a success would be rolling a 5, even though a failure will be rolling a 1, 2, 3, 4, and 6. I can lump that together and say the chance of failure is 5/6, where the chance of success is 1/6. Okay, so you're able to kind of clearly differentiate what a success is and what a failure is. The second is that the probability of success will be the same on every trial. That as I do it repeatedly, the chance of success will be constant. Okay. The third is that each trial is independent. Okay, so that one trial doesn't affect the next one happening. Okay, and that's usually true. Down here below, I've talked before about if we have a huge deck of cards, like 1,000 cards, and we're drawing without replacement, it will not make that big of a deal because there's so many cards. The rule of thumb that we have to work with now is that as long as what we're sampling is less than 10% of the entire population, it doesn't really matter if we're drawing without replacement, okay? Because we're pulling such a small part of our population that it doesn't necessarily have to be independent. So let's jump into the geometric model. In the geometric model, the big question we're asking is how long will it take us to achieve our first success? Okay, so in the geometric model, we're taking in one parameter, and that is the probability of success. Okay, and we can look at the probability that success will happen, the first success will happen on the 4th trial, or the 7th trial, or the 10th trial, or the 2nd trial. Okay, we're looking at the very first success. Okay, and now I hope this equation down here makes sense, because if to get our first success, we would have had to have 1 minus that number of failures. So if my first success is on the 5th trial, then I would have had 4 failures and then my 1 success. So we'll look at the probability of failure to the power of x minus 1 times the probability of that first success. Okay, now the expected value is 1 over p, which I hope makes sense because I'm rolling a dice and my success is, rolling a 5, there's a 1/6 chance of that happening. I'd expect to get my first success somewhere around my 6th roll. Again, it could happen earlier or later, but on average, if I do it a lot, I expect it to happen on average every 6th roll. Okay, the standard deviation is a little more complicated, but it's sigma is equal to the square root of q over p squared. And let me point out again that q is the probability of failure. Okay, here is the TiTip. It's under the distribution part of your calculator. Geomet PDF is looking at one specific, the probability of success is 0.2. I'm looking at the chance that my first success happens on the 5th trial, and that is this 0.08 is the probability, or Geomet CDF is that or less. So the probability of success is 0.2, and I want to look at the chance of me getting my first success on or before the 4th trial. Okay, with that, the binomial model. Now the binomial model looks at the number of successes in a fixed number of trials. Okay, so if you're going to do something 10 times, what's the chance of having two successes or 7 successes? It looks at a specific number of successes within a specific number of trials. Okay, and the math on this is helpful. There's this notation of n choose k, which you may probably have seen the nck notation in earlier math classes. And as you move on to more college mathematics, you'll see the parenthesis n over k notation used more often than the nck notation. Okay, but that still is the number of ways that we can order k things among n things. Okay, and also down here we'll look at if you're looking at um, 2 successes out of 5, then you will need 2 successes and 5 failures, and you multiply that probability times how many ways you can order those 2 successes among the 5 trials. Okay, so that's where the formula comes from. But here is our handy dandy box that tells us the probability of getting X successes out of N trials is N choose C, the number of successes to the X power times the number of failures to the N minus X, which is the number of failures you would need to have N, X successes. Okay, the mean would be N times the probability of success, and the standard deviation would be the square root of N times P times Q. Okay. Also, I forgot to scan it in, but also check out the TiTip on page 296 about how to plug in a binomial question into your calculator. Okay, and that's it on the first part of chapter 17.